Hello and welcome to this session. In this session, we'll be talking about the logical database design. In our previous session, we tried to demystify the conceptual design, where we, at the end of the video, formulated this entity relationship diagram. So we spoke about the entities, we spoke about the attributes, and also spoke about the relationship between the entities. So in this video, we'll be talking about the logical database design. I was trying to make us understand what logical database design means. And on the internet, I found this definition by Boriga in his paper called Logical Database Design, and it was really great. So they define the logical database design as the process of transforming or mapping a conceptual schema of the application domain into a schema for the data model underlying a particular database, such as a relational or object-oriented data model. I feel this definition is very concise and it's about perfect, but it might be a little bit confusing. So, what this whole definition is trying to say in simpler terms, what we are just basically trying to do is we are trying to translate the elements of the conceptual model into the element of the database model. So that is what this part of the definition is trying to say. The logical database design is the process of transforming. So what you're trying to transform, what we had previously. So previously we had the conceptual model. So now from this conceptual model, we are trying to go to the logical design. So that is basically what the definition is trying to say. And we'll try to see how we could do that in the following slides. And basically, before we go to the next slide, it just basically involves, for example, where we have our entities. We previously had our entities here. These are our entities, and these are entities. So we convert these entities, we convert them into tables. And we have our attributes as well. These are the attributes of the entities. We convert the attributes of the entities into columns. Basically, that is what the definition is trying to explain to us. So let us look at the overview of the logical design process. So basically, the first thing we have to do is to map our classes into tables. That is our entities. We have to map our entities into tables. And after we've done that, we have to create tables for multi-valued attributes. Sometimes we have some attributes that are multi-valued. And remember, in our previous sessions, we spoke about storing just an atomic value for each attribute. So for attributes that have more than one values, we have to create another table for them. And finally, we have to represent the relationship. In the last session, we spoke about different type of relationship. So we have to represent the one-to-one relationship, the one-to-many, and the many-to-many relationship. So let's take an example. So the very first step says we should map entities or our classes into tables. So in our previous session, we had this entity, we had the borrowers. In the example where we said the books can be borrowed by different borrowers, so we just brought out the entity, which is the borrowers, and the attribute. So the first thing we need to do is to translate this entity into a table. So to do that, this is the procedure to do that. So we have a borrowers table. So this way, we've gone from entity. This is an entity. We've gone from entity to a table, and now that's what this is trying to say. Map each entity or class into a distinct table. And the next thing is each attribute is a column of the table. So all these attributes would eventually form the column of the table. So let's look at something like this, just to bring the point home properly. So we have a table. So let's assume this is our table, and now this will be the borrowers table. So I'll just represent that with B, right? And now we have multiple attributes. So we have this attribute, we have the borrower's ID. So there will be a column for the borrower's ID. So here will be the borrower's ID. Then also for the borrower's name, we'll create another column. So basically, this is what we are trying to do. This is what this point is trying to do. So the first thing is to map each entity into a distinct table. So this is the table of the entity, right? So after we've mapped the entity, the next thing is to turn the attributes of the entity. We have to turn them into columns. So basically, that is what that's trying to explain. Then the next thing is for complicated attributes, we have to divide them into separate columns. And finally, we choose a primary key. So for example, sometimes we have complicated attribute. For example, we have name. So instead of having name in just one table, we have to create two different. Instead of having pardon me, instead of having name in just one column, we have to create another column, because it's a complicated attribute. So remember, in our previous video we mentioned that for every we mentioned that for every attribute we have to have just an atomic value. That means for the id we have to have just one value. For example, let's say we have the first name, so I'll represent this with fn. So if this is the first name, or let's say we have just name, so let's say we have name, so I'll just represent this with n. So my name is Aremu Babatunde, so I cannot have Aremu and Babatunde in the same row, right? It has to be on the next row. It has to be on the next row. We have to have just a single. So I have to have just Aremu. So I have to just have Aremu here and maybe Babatunde in the next row. So we cannot have two values in one cell. Each cell has to have an atomic value. That means it has to have a single value. So what we have to do, so since the name is a complicated attribute, so we have to change it to just first name, and we have to create another colon for, let's say, the last name. So we create another colon for last name. So now it gets easier to for our database to work with this. So now we can have just Aremu here, and now we can have Babatunde or David here. So that's what that is trying to explain for complicated attributes. Then after we've done this, we have to choose the primary key. So the primary key is a way to uniquely identify items in our table. So we would use the borrower's ID as the unique ID. So the next thing is to create tables for, after we have mapped the entities into classes, the next thing is to create multi-valued, the next thing is to create tables for multi-valued attributes. A multi-value attribute is an attribute that can have multiple values for a single occurrence of an entity. For example, let's look at a person's phone number. So a person can have like different cell phones, and a person can also have different, on the same cell phone a person can also have different numbers. So when we have attributes like this, we have to create a new table for them. So considering this example of a logical database design for a school where each student can have multiple phone numbers. Now, in this scenario, we'd create another table. We are creating another table completely. Previously, in the previous example, we just created new columns to store the values. But now, when it gets so much, it won't be effective to create just new columns. So the best thing is to create a whole new table. So now we have the students, right? We have students, and these are the attributes of the students: the name, the student's ID, the department, and the phone number. Since the phone number it's a multi-valued attribute, then we have to create a new table for it, and we have to store the primary key in the table as well. Then we have the phone numbers. So I hope we understand that. Now the next thing we have to do is to represent relationships. We have to okay, so this is how it's going to look like. So this is the logical design. So we have the student table and we have all the attributes, but since we explained earlier that the phone number is a multi-valued attribute, so we have to create a new table completely for it, and this is the new table, and now these are the attributes of it. So the next thing is to represent relationship. How do we represent relationship? We have different relationship like we discussed in our last session: one-to-one, one-to-many, and many-to-many relationship. So the first thing is to represent the one-to-one relationship. So it's a little bit flexible. It's very much flexible to represent a one-to-one relationship. And why we're representing this relationship in our logical model is basically to enable us to get data, to enable us to join our data together so we can actually query better. So what we have to do is to put the primary key of one of the tables as a foreign key in the other table for relationship which their cardinality is one-to-one. And we can also do the same thing, like putting the primary key as a foreign key in both tables. So what I've explained might be a little bit complex, so let's try to practicalize it out. So now we have this relationship, we have this entity relationship diagram whereby a parent stays a patient stays in one room. Let's say this is an hospital database, right? So now this is a one-to-one relationship. So how do we represent this in a logical design? So to represent this in a logical design, what we have to do, once we create this patient table, so we create the patient table, and after we create the patient table, we put the attribute, and we do the same thing for the room. Now how do we connect these two tables together? We have to connect these two tables together by representing we have to connect these tables together by putting the primary key as a foreign key in another table. So we have to put this primary key, the patient ID, as a foreign key in this room table. So there are different ways to represent this relationship. We can do it by putting the primary key of one of the tables in the other table, or we can either represent both primary keys in both tables. So there are three different ways to do that. So the first way is, now when we have the patient table, now this is the patient table, and this is also the rooms table. Now we can see that from here we have put the patient ID, which is the primary key here. We introduced it here as a foreign key. That is one way to do it. Another way to do it is to have this room ID as a foreign key in the patient table. That's another way to represent the relationship. And the final way to represent the relationship is to include both primary keys as foreign keys in the corresponding tables. So this is the third way to do it. So we have the room ID here, and we also have the patient ID here. It's a little bit redundant, but it also works. So any of these three method will work to represent one-to-one relationship. So next we have to look at one-to-many relationship. So for one-to-many relationship, what we have to do is to put the primary key of the one table in the many table. So let's just look at an example. So now we have this entity relationship diagram where one teacher teaches many students. So this is a one-to-many relationship. Now how do we represent this in the logical model? So to represent this in the logical model, we have to put this teacher ID in the many table, and that is how we can like create a connection, like to perfectly join the table and like make queries from this from the database. So this is what I was trying to explain. We have the teachers table, and we have to add the teacher's ID as a foreign key in the many table. So this is how it works for relationship that are one to many. You have to put the foreign the primary key of the one table as a foreign key in the many table. Now the last relationship is the many to many. So for many to many relationship, what we have to do is to create a whole new table for the relationship. So basically, for many to many relationship, we would have to create a new table, and now we'll put the primary keys, the two primary keys, we'll put it together in the new table. So we have to create a new table called borrow. So now we have this table, which this is the book table, and these are the attributes in the book table. We have the borrowers also, and these are the attributes. Now how do we represent the relationship? To represent the relationship, you have to create a new table, and the new table will contain both table primary key. So that is the way to represent many to many relationship. So I want us to do this demo. So basically we have this persons table, we have this address table. So we have this is we are trying to make it a little bit more complex and try to combine different entities. So now this basically, we have a person staying at a particular address, so that is one-to-one relationship. And we also know that a person can have multiple phone, right? So now how do we represent this relationship? So to show how we represent this relationship, we would we'll just have a text box here. So the first thing to do is to create the tables. So let us create the first table. Now the first table is the person table. So we create a person table. Now after we've created the person table, the next thing we want to do is to create the columns, right? So what are the attributes to make up the column? So now we have the person ID. After the person ID, so I'll underline this because it's the primary key. Now we have the person's name. and finally we have the person's age. So now the next thing again is to represent the address table. So we have to create, now we have this entity, right? And now then we convert this entity into a table. Now to do that, we say address. Now for this address, I'll make it bold since it's the table. Then now we have to represent the attribute. So we can have the address ID, then another attribute. Now this attribute, we are converting them into columns. So we have the streets, right? And finally we have the city. So for one-to-one relationship, remember from our previous explanation, we can have, so let me just say person ID. Let me just change this to person ID. Now we can represent, now this is also the primary key. Now to make this relationship perfect, we can either put this here to form a join, right? Or we can actually put this, yeah. So there are different way we've explained in the previous slides. So we can do this, right? This is a way to represent the one-to-one relationship. But for me, it's a little bit redundant to have both primary keys as foreign key in the associated entity, or in the associated tables. So I'll just remove this and just leave it like this. So this way we can like create a connection. Now the final thing to do is to represent the phone, right? So this phone, the relationship is one to many, and as we've explained previously, we put the primary key of the one table as a foreign key in the many table. So to do that, we just have something like this, and now we can have the phone ID. Now this is the primary key of the phones table, so we underline this. Next we have the number, so the number the person is using on the phone, and probably the type of the phone. We want to know what type of phone the person is using. And finally, to create a way to like join these two tables together, we have to have this person ID, which is the primary key of the person table, as a foreign key in the many table of the which is the phones table. So this is a way to convert our conceptual model. This is our conceptual model, the ER diagram, and we convert it to the logical design. So the next thing is to start the physical design, because the logical design, it just basically provides a blueprint for the physical implementation. So with this, we can go to any of our softwares, but we'll be using Postgres, and we can like create our table and store the attributes, and start querying and start getting real results. So in our next session, we'll be talking about SQL. So stay with us, and thank you for watching.